today we're going to be talking about variation. So when two variables relate by a constant variation, we can talk about direct or indirect variation. In this video, we're going to specifically be talking about direct variation. The variation constant is generally represented with the variable k, and it describes the relationship between the two variables. And this does not change. That's why it's called the constant variation. Examples of variation could be like your work. So you work a certain number of hours and you make a certain amount of income. If you get an hourly rate, if you're paid so much money per hour, this is a constant variation. You work more hours, you get paid more, and it varies by a specific constant. In general, direct variation means that as one variable increases, so does the other. You work more hours, you get paid more money. This is a direct variation. And we say it is said that y varies directly as x if y equals k times x, where k is that variation constant. So let's look at some examples of what this means. Over here on the left, it says y varies directly as x. So we can set up our equation based on just that sentence. So y varies directly as x. Y will vary directly, so that variation constant times x. Now it says if x equals 4, then y equals 36. Let's plug that information in. Y is 36. We don't know the variation constant, and x was 4. So our first step is generally to find that variation constant. So to solve for k, I divided both sides by 4, and k equals 9. So first step, find variation constant. Second step, solve for a different specific value. So it says find y when x equals 8. So we don't know y. We do know the variation constant is now 9, and we're letting x equal 8. So y would be 72. And that's the way we're going to solve these direct variation problems in general. You have to find the variation constant and then solve for a specific value. Let's look at this next one. It's now more of a story problem. It says Julie's paycheck varies directly with the number of hours worked. If she works 38 hours, then she makes $427.50. How much will Julie make if she works 35 hours? So we still have to find that variation constant, and in this case the variation constant is how much she makes per hour. So we know that it's going to be her paycheck varies directly with the number of hours worked. So the paycheck is like our y, and the number of hours worked is like our x. In the first or the second sentence, it says if she works 38 hours, so again, x is the number of hours, and she made $427, so that's her paycheck. We can now find that variation constant, or the amount she makes per hour. We divide both sides by 38, and we get 11.25. So she's making 11.25 per hour. The next question is, how much will she make if she works 35 hours? So now we want to know her paycheck. We know the variation constant, and we know the number of hours worked. So we just have to multiply 11.25 times 35, and we get $393.75. Go ahead and try the two examples on the right-hand side. The next example says P varies directly as T. Okay, so it's different variables, but it's the same idea. Oops. So P varies directly as T. Right? So P came first and it's varying directly. So then that means it's K times T. Then it says if T equals 6, then P equals 24. So I plug those in. 24 for P, don't know K, T is 6. Divide both sides by 6, and K equals 4. So that's the first half of our problem. Now we know the variation constant. Now that I know that, I can find P when T equals 5. So I don't know P, I know the variation constant, and T was 5. So P will be 20 when T is 5. There's our solution. The next one says, according to Hooke's law, the force needed to stretch a spring is directly proportional to the amount the string is stretched. So the force is directly proportional. That's the same thing as saying varies directly. Directly proportional to the amount the string is stretched. That's to stretch. So the force varies directly to the stretch. So that's going to be our equation. I'm going to go ahead and use F for force. We don't know the variation constant. And instead of using an S, I'm going to use an X because sometimes my S's look like 5s and I don't want to get confused. So force varies directly as the stretch. Then it says, if 25 pounds of force stretches a spring 5 inches, how much will a spring be stretched by a force of 45 pounds? So that first half is how we find our variation constant. The force is 25 pounds. Then it stretches the string 5 inches. We solve for that variation constant and get 5. Now that I know the variation constant, I can find the other half. How much will the spring be stretched by a force of 45 pounds? So now we know the force, we know the variation constant, we don't know how far it stretches the string. Divide both sides by 5, and we get 9 inches. So if you have 45 pounds of force, it'll stretch the string 9 inches.